In this video session, we shall discuss about how to determine volume of an ellipsoid x square by a square plus y square by b square plus z square by c square equal to 1 by triple integral. First, I will draw the ellipsoid in that's a three-dimensional structure. I will take y-axis, x-axis and z-axis. Ellipsoid is a three-dimensional structure that is an extension of ellipse in 2 dimension to 3 dimension. So something similar to this, we'll get an ellipsoid. Here, this ellipsoid will intersect with each of the axes x, y and z. The point of intersection with x-axis would be A, 0, 0. Point of intersection with y-axis will be 0, B, 0. Similarly with z-axis is 0, 0, C. Now this ellipsoid you can observe which is a symmetrical structure with respect to, even if I take YZ plane or XZ plane or XY plane. Because it is symmetric with respect to all these three planes, we can write volume of ellipsoid is equal to 8 times volume in first octant. That means we have to determine only volume of this ellipsoid in the first octant. If I multiply that by 8, I will get volume of the ellipsoid. So I'll take this is 8. Now for the first octant or for any three-dimensional object S, volume is given by triple integral of dx, dy, dz. There will be no function of integrand function, or integrate function is nothing but 1 here. Okay. So to determine this integral or evaluate this integral, first we need to write the limit for this integration. Now this is equal to 8 times of, I will take the order of integration as dz, dy and dx. That means first I have to integrate with respect to z, then with respect to y, finally with respect to x. Now first I have to write the limit for z. Now this is something like this. We have in the below portion, this will be plane y, x and z. Imagine this structure. Something like sphere only, little bit different shape. Okay, this structure. Now first I have to write the limit for z. I will write here. You observe here in this solid, z varies actually vertically, right? So z will start with the plane xy. On that plane, z value is 0, and z will end at the ellipsoid here. On the ellipsoid, z is given by, z square is given by, we can write c square into 1 minus x square by a square minus y square by b square. So z will be c into square root of these terms. We'll get plus or minus, but in the first octant, that is above xy plane, z will be positive. So we will have the lower limit is z is equal to 0 and upper limit is root of 1 minus x square by a square minus y square by b square into root of c square, that is c only. Now once we write this innermost integral limit, 3 dimension is over, we have to reduce this structure to 2 dimension. So when I take this structure to 2 dimension, to reduce that, we have to take the projection of this structure, this solid, onto the xy plane. Remaining variables are y and x, so we will take xy. Suppose if I have written dy, then remaining variable will be z and x. Then we have to take the projection on zx plane. That is, here we have to take. If I had dx here, then remaining will be x, z and y. Then we have to take the projection onto yz plane. Okay. Now, if I take this projection of this object onto xy plane, we will get actually, that is, I'll take a projection of complete ellipsoid. We will get an ellipse with the equation as x square by a square plus y square by b square is equal to 1. But we want only in the first octant, that becomes the first quadrant. That is x here, y here. Now I have to write the limit for this integrating region. In this region, that is, this point is a comma 0 and this point is 0 comma b. So, and this is the equation of the ellipse, x square by a square plus y square by b square is equal to 1. Now, we have to write the limit for y. In this 2 dimension, y again varies horizontally. So, lower limit is 0 and upper limit is this ellipse, that is b into under root 1 minus 1 minus x square by a square. So that is the limit for y. Now x limit we have to write. X will varies, that's the minimum value. Minimum value of x is y axis, that corresponds to x is equal to 0. And maximum value of x is up to x is equal to a. So upper limit will be. So this is the integrand. So by evaluating this integration value, we will get the volume of the ellipse. I'm not going to discuss about the integration part. This part of writing the limit is important. So once you understand how to write the limit, the remaining part you have already discussed in many places. So I'm not going for remaining part. If you complete this, you will get 4 by 3 AP by ABC.